So in last lecture, we started with definite integration. We solved few problems. Let's take few more problems. So here I'm taking from exercise 4.2, first and fourth. So let I equals to negative pi by 4 to pi by 4, 1 upon 1 minus sine x. Now we are right now dealing with those questions where we need not be where we need not be applying on new ideas so far as integration is concerned. What I mean to say is these questions, these problems we have already integrated. We have already integrated in our indefinite integration chapter. Here we are doing the same integration under interval. So here interval is minus pi by 4 to pi by 4. So I already know how to integrate this. Minus pi by 4 to pi by 4, and to integrate this I will write 1 minus sine x and multiply 1 plus sine x in numerator and denominator. So when I do this I will get minus pi by 4 to pi by 4, 1 plus sine x in numerator, and in denominator I get a minus b multiplied to a plus b, a square minus b square, that is 1 minus sine square x, which is cos square x I will get in the denominator. So next step is I'll get, therefore I equals to, I will separately divide by the denominator cos square x, so I get negative pi by 4 to pi by 4, 1 over cos square x plus sin x over cos square x dx. So which is I equals to negative pi by 4 to pi by 4, 1 over cos square x is sec square x, and this is sec x into tan x. Sec x into tan x. Very simple problem. We will write separate integral for both these functions. So negative pi by 4 to pi by 4 sec square x dx, sec square x dx, plus negative pi by 4 to pi by 4 sec x multiplied to tan x dx. Integration of sec square x is tan x. So here I get tan x and negative pi by 4 to pi by 4. Integration of sec square x is tan x. So tan x and negative pi by 4 to pi by 4 plus integration of sec x tan x is sec x. Negative pi by 4 to pi by 4. What I write next is upper limit minus lower limit. Okay, integration is over. Now I will evaluate the upper limit minus lower limit. So what does that mean? In this tan x, inside the bracket, wherever x is there, I will put first upper limit pi by 4 and then put lower limit minus pi by 4. So the next step I will get I equals to tan pi by 4 minus tan of minus pi by 4. Okay, tan pi by 4 minus tan of minus pi plus here I will get sec pi by 4 minus sec of minus pi by 4. So I get I equals to tan pi by 4 is 1. Now we know that tan negative theta is negative of tan theta. If you remember, tan of negative theta is negative of tan theta, and we also have sec of negative theta. So sec negative theta is sec theta. It is sec theta. So the next step I get 1 plus tan pi by 4. That negative tan theta when I write, so this negative will become positive. 1 plus pi by 4 plus sec pi by 4. Cos pi by 4 is 1 over root 2. So this is root 2 minus sec, this minus will remain minus because sec negative theta is sec theta, and sec pi by 4. Okay, so I get I equals to 1 plus 1 plus root 2 minus root 2 plus root 2 minus root 2. So I equals to, the answer is 2. This is your answer. Okay. Let's go for the another question. This is ninth from the same question. I equals to 0 to pi by 4, 0 to pi by 4 sine raised to 4x dx. Okay. Now see, I have already taught you how to integrate sine square x. When we have to integrate sine square x, we write sine square x as 1 minus cos 2x upon 2. For sine square x, we always write this and then we integrate. Okay. But this is not sine square x. What it is sine raised to 4x. So what we will do, see, the idea will remain same. See, I will go ahead with, I'll write 0 to pi by 4 and sine raised to 4x, I will write sine square x the whole square dx. Okay, I'll write sine square x the whole square dx. Then the next step is, I'll write therefore I equals to 0 to pi by 4 and sine square x is 1 minus cos 2x upon 2 the whole square. So I substitute for sine square x. Now this is, so I equals to this denominator 2. So 2 square is 4. So I get 1 by 4 out, 0 to pi by 4. And here I get 1 minus cos 2x, the whole square dx. Okay, 1 minus cos 2x, the whole square dx I get. So see the next step. I get I equals to 1 by 4 and 0 to pi by 4, 0 to pi by 4, it's the identity a minus b the whole square. So a square minus 2ab, okay, 2ab, 1 square is 1, 2 into 1 into cos 2x is 2 cos 2x, 2ab plus b square, that is plus cos square 2x and dx. Now I write separate integral, so I 1 by 4, I write separate integral for all. And this 1 by 4 is common for all, so I write a bracket outside. This is 0 to pi by 4, 1 dx. Then integration of this I write, so which is z minus 0 to pi by 4, 2 cos 2x dx, 2 cos 2x dx, plus 0 to pi by 4, 0 to pi by 4, and cos square 2x dx. Cos square 2x dx. Cos square 2x dx. Now see, rest all is fine. I put this in a bracket. Okay, this is inside a bracket. This bracket closes there. Now rest all is okay. See, I'll be able to integrate 1 in the next step, which is x. I'll be able to integrate this also. 2 cos 2x. So this 2 I will write out. The only question is how to integrate cos square 2x. So cos square 2x, I will have to write once again formula for cos square 2x. See, if you remember, I said when we have to integrate sine square x, what we write? We write 1 minus integration of sine square x. There is one and only one method you have. If you know this, it's good. If you do not know this, just forget it. You won't be able to integrate. So sine square x dx, you write 1 minus cos 2x upon 2 and you integrate, right? If you have cos square x, then what would you write? For cos square x, you just change this negative sign with positive. So integration of cos square x is you write 1 plus cos 2x upon 2 dx. This is what you do for cos square x. Okay. Now here I have cos square 2x. So what would I do for cos square 2x? See, cos square x, you write 1 plus cos 2x by 2. So when it is x, you write the angle 2x. Okay, so if it is 2x, this will become 4x. What it will become 4x. So for cos square 2x, you would be writing 1 plus cos 4x upon 2 dx. This you write for cos square 2x. Okay, these are the trigonometric formula that we know for quite long. We know this for many days. This we have done in 11th standard, this trigonometric formula. So 1 by 4 is out. And then here I have integration of 1 dx, 0 to pi by 4. Okay, then minus 2, this 2 is constant, this 2 is constant, I wrote it out, minus 2, then cos 2x, 0 to pi by 4, okay, plus, here I write 0 to pi by 4, and cos square 2x is 1 plus cos 4x, 1 plus cos 4x upon 2 dx, and the bracket is closed. Now we can integrate this. So what will happen? This 2 will also go outside. Here it will come. In next step, it will be written. This 2 will be written outside. So here now, the next step, I integrate all. So I get 1 by 4 and then bracket x 0 to pi by 4. Integration of 1 is x. Integration of 1 is x, and I write that x in a bracket 0 to pi by 4 minus 2. Integration of cos 2x is sine 2x. Divide by 2. Don't forget to divide by 2 because coefficient of x is 2 and 0 to pi by 4 plus 1 by 2 I write out. 1 by 2 is written out, and then integration of 1 plus cos 4x. So see here, integration of 1, this 1, integration of 1 is x. Okay, so x plus integration of cos 4x. Integration of cos 4x is sine 4x upon 4. Sine 4x upon 4. The integration is over. Put this in a bracket. Again 0 to pi by 4 and bracket closed. This much you have written. Okay, now next step is upper limit minus lower limit. Before that, one more step we can do. So you know what? Now what I would like to do is I 1 by 4. This is here I get upper limit minus lower limit. So this is pi by 4 minus 0. Wherever x you have, you write upper limit. So x upper limit is pi by 4. So you get pi by 4, and then you write the lower limit, you get 0. Now this 2 and this 2 cancel. This 2 will be outside as 1 by 2, and it will get cancelled. So you have that 2 cancelled. So you have minus, and here you will apply upper limit minus lower limit. That is, wherever x is there, you will write upper limit. So this is sine of, okay, I put a bracket here because outside I have a negative sign. See, this negative sign is here. So I need to put a bracket. Sine of x, sine of 2x. What is x? X is pi by 4. So sine of 2 pi by 4. It is sine of 2x. So it will be 2 pi by 4. 2 pi by 4 is pi by 2. Minus sine of 2 times 0. 2 times 0 is 0. So sine 0. Okay. Then you have again upper limit minus lower limit for this. So this 1 by 2. And now put upper limit. Where do you put upper limit? In this box, in this bracket, wherever x is there, you will write pi by 4. Okay, wherever x is there, you will write pi by 4. So see, you get here x is replaced by pi by 4. So pi by 4 plus. Now put here, you put x is pi by 4. So it is 4 pi by 4. So 4 pi by 4, you get 4 cancelled. So you get sine of pi. Okay, what do you get? You get sine of pi. So you get sine of pi upon 4. This is upper limit. This is upper limit. Okay, pi by 4. Pi by 4 plus sine pi the whole upon 4 you are getting when you are putting x as pi by 4. Now you will put x as 0. So when you put x as 0, see what you will get. You will get minus lower limit. This is 0. This is 0. Okay. And plus. So this plus will also become minus, minus. And here what you have? You have sine of 4 into 0. Sine 0. Sine 0 is 0. 0 upon 4 is 0. So in fact, when you are putting lower limit, this becomes 0 and this also becomes 0. Both are 0. So lower limit is ultimately giving you what? The lower limit is giving you 0 only. So minus 0. Upper limit gives you this. Upper limit gives you this. Lower limit gives you 0. Okay. So you got this. This is. And then you see. You complete the final bracket and also complete this bracket. So the next step you get is you get I equals to 1 by 4 outside, pi by 4 minus sine pi by 2 is 1, 1 minus 1. Okay, sine 0 is 0, just forget that, plus 1 by 2, and you have here pi by 4 plus 0. Sine pi is 0, so that is 0 by 4, 0. So you get here 1 by 4 minus 1, 1 by 4. So the final answer you get is I equals to 1 by 4. Inside the bracket, you get pi minus 1 plus pi by 8. Plus pi by 8. You get pi minus 1 plus pi by 8. Okay. So this is 1 by 4, and take LCM. Take LCM for this and this. Okay, these are terms in pi. So you take LCM and solve. So LCM is 8 here. So you get 9 pi by 8. 9 pi by 8 minus 1. This is final answer. Okay, I hope you all must have followed. You can just go through the whole solution once again. Okay, and here, if you want, you can write and evaluate upper limit minus lower limit. What did I do? I did not write that part. I simply evaluated. Okay, if you want, you can write it in detail and do that. Thank you. Yeah, students, there is a correction here. This pi by 4, I wrongly copied in the next step. It should be pi by 4 here. So what you get next is, here you have, this is pi by 4 rather. Okay, this is pi by 4. So the last answer would change. The last answer will change, and what you will get is, this is 1 by 4, and when you take LCM for this and this, the LCM is 8. So you get here, this is 3 pi by 8 3 pi by 8 minus 1. You get here 3 pi by 8 minus 1. So let's take one more problem. Negative 4 to 2, 1 upon x square plus 1 upon x square plus 4x plus 13. Now in this question, the denominator which I notice, it is a quadratic expression. So when I see any such problem, so it is actually 1 upon quadratic type. I have explained 1 upon quadratic much in detail in indefinite integrations section. So you can see that video from indefinite integration. 1 upon ax square plus bx plus c dx. Now, whenever I have 1 upon quadratic, you may say 1 upon quadratic, or you may say 1 upon ax square plus bx plus c. When you have such a type, what you do is, you first try to find the factors, because if you could get factors for this expression, if you could get the rational factors for this expression, okay, if you could factorize, then you will go for partial fraction method by dividing it into two fractions. Okay, because you will get two factors. Okay, linear factor, then you can go for two fractions. But here I notice that I am not able to get the rational factors for this expression. Okay, because I won't be able to split this 4 into two numbers such that, two rational numbers such that the product is 13 and the sum is 4. So what I will do, I will go for the method of completing square. I will go for the method of completing square. That is getting a perfect square here. So for that, I will find out the last term. What is the formula for the last term? Last term formula is half the coefficient of x, the whole square. So what is coefficient of x here? 4. So half of 4 is 2. Okay, 1 by 2 into 4. Half of coefficient of x. So half of 4 is 2 and square, so I get 4, right? But remember students, this formula you use this formula only when the x square coefficient is 1. So here x square coefficient is 1, that's why I could use it. If you notice that in any expression, quadratic expression, the x square coefficient is not 1, in that case you will first make it 1. So next step I get is negative 4 to 2, 1 divided by, I have here x square plus 4x plus 4 plus 9. What I did, this 13 I wrote 4 plus 9. Now this gets me the square completed, okay, and at the same time I am getting another square. 9 can be written as 3 squared. So the next step you will all write as I equals to negative 4 to 2 and 1 over, see here, 1 over, the first three terms are now a perfect square. It is x plus 2 the whole square, and 9, this 9 I can write it as 3 square. Okay, so what is this now? This is 1 upon, now this is a result. Which result? If you remember, we had 1 upon x square plus a square dx. Okay, we have already done this in indefinite integration. There in indefinite integration, when I taught you this, I termed it as, I classified it as set one theory. Set one theory. It is 1 upon variable square plus constant square, and its integration was 1 upon a tan inverse of x over a plus c. So now here the variable is x plus 2, x plus 2. So we will get here I equals to I equals to, now I integrate this, so 1 upon 3, 1 upon a, so 1 upon 3 tan inverse of x plus 2 upon 3 and the limit negative 4 to 2, okay, and then this. So now, okay, please see here. Now here, very important, good that we come across this problem. You know, this 1 upon 3, this 1 upon 3 will go outside the bracket. This 1 upon 3 will go outside the bracket. Okay, it is detachable constant. But remember, don't take this 3 outside the bracket. This will not go outside the bracket because it is not multiplied to the function. Rather, it is the part of the angle. So it is the part of the angle, that is, it is going directly to the function. Okay, so this 1 by 3 I will write out in the next step. So I have 1 upon 3 out, and tan inverse of x plus 2 upon 3. I have here negative 4 to 2. So the next step I get I equals to 1 upon 3 upper limit minus lower limit. Here I go upper limit minus lower limit. So wherever x I have, inside the bracket, I'll write the upper limit. So tan inverse of, this is 2 plus 2 upon 3, 2 plus 2 upon 3 upper limit minus lower limit. So this is tan inverse of, here I have minus 4 plus 2 upon 3, minus 4 plus 2 upon 3. This is what I get. So the next step I get is I equals to 1 by 3 tan inverse of 4 by 3 minus tan inverse of minus 1 by 3. Okay, and please remember that tan inverse of minus x is minus tan inverse x. Remember this, tan inverse of minus x is equal to minus tan inverse x. Okay, so in case if you do not know this, note it down. So here you will have I equals to 1 by 3, and this is tan inverse of 4 by 3. This minus will come out plus tan inverse of 1 by 3. Tan inverse of 4 by 3 plus tan inverse of 1 by 3. Okay. After this, I will use a formula, one more formula we have, and that formula is, let me write that formula. That formula is tan inverse of A plus tan inverse of B is equal to tan inverse of A plus B upon 1 minus AB. Now we are going to use this formula. This formula we have done in derivatives and also in inverse trigonometric function. Tan inverse of A plus tan inverse of B is tan inverse of A plus B upon 1 minus AB. So here what shall I get? I'll get I equals to 1 over 3 tan inverse of A plus B upon 1 minus A into B. 1 minus A into B. So this is I equals to 1 by 3 and tan inverse of 1 by 3 plus 4 by 3. This is 5 by 3 divided by 1 minus 4 by 9. 1 minus 4 by 9. Okay, so this is I equals to 1 over 3 and I get here tan inverse of 5 by 3 and this is 5 by 9. So this 5 and 5 cancels. I get next step I will get here I equals to 1 upon 3 tan inverse of 5 by 3 into 9 by 5. 5 cancels. So 1 by 3 into tan inverse of 3. This is final answer. You can watch this complete solution once again and do it. Okay, students, see, there is a mistake committed here. I will rectify that mistake. This is minus 2. So this will become 2 by 3. See, the mistake I committed was minus 4 plus 2 is minus 2. So this is negative 2 here. And this minus will go out. So it will be plus tan inverse of minus x is minus tan inverse x. Tan inverse of minus x is minus tan inverse x. So you will get here that minus which will go out, it will make it positive. Tan inverse of minus x is minus tan inverse x. So this minus which you are getting outside, it is making this positive. So you have this, after using formula, it will be 2 by 3. So this is not 5 by 3, rather it would be 6 by 3. This will be 6 by 3. Okay. And here, this is 6 by 3. And here it is 2. Here it is, this is 2 by 3. This is also 2 by 3. So because it is 2 by 3, this will become 8 by 9. This will be 8 by 9. And then, see, you need to be alert because mistakes can happen with anybody, you know. So I'm sorry. You shouldn't be doing it. So 6 by 3 is 2 and here 9 minus 8. So this is 1 by 9. Okay, 9 minus 8 by 9, this is 1 by 9. So this would become tan inverse of 18. So the answer here is, you get the answer as tan inverse of 18. This is final answer. You get it as I equals to tan inverse of 18. Okay, yeah, that's it. Mistake rectified. Let's take one more problem. I write this as this integral which I have to evaluate. This integral is in the interval 0 to 1. It is a definite integral. So, and the integration is 1 upon square root of quadratic. It is 1 upon square root of quadratic. That is 1 upon square root of ax square plus bx plus c dx. You know the method. We will complete the square here. What we will do? We will complete the square. Okay. So while completing the square, the first step is, if you remember, I always say that you have to find the last term, but the last term you can apply the formula only when the first term, the x square coefficient is positive 1. So here I will first make coefficient of x square as positive 1. So this is 0 to 1, 1 upon square root of, I take negative sign common, I get x square minus 2x minus 3 dx. X square minus 2x minus 3 dx. Now I will, please don't take this negative sign outside the square root. That is not allowed. It will be wrong in that case. You cannot take a negative sign outside the square root. So now I find out the last term. The last term is half the coefficient of x. So coefficient of x is negative 2. Half of that, so you will get negative 1. And then what you will do, you will write the square of this negative 1. You write the square. So square of negative 1 is 1. So the last term here is plus 1 minus 1. What is the last term? Plus 1 minus, last term is plus 1. So you will write plus 1. And since you are writing plus 1 from your side, you will have to compensate that adding 1 by subtracting 1. So 0 to 1, you have 1 upon square root of negative, then you have x square minus 2x plus 1, then write minus 1 minus 3 dx. Minus 1 minus 3 dx. Next step you have, therefore I equals to 0 to 1, 1 upon square root of negative, and then inside the bracket you have, see, this 3 will get you the perfect square. What is it? It is x minus 1 the whole square, and this minus 1 minus 3 will get you negative 4. Okay, that will get you negative 4, which I can write minus 2 square. And then see, what is next step? Next step is, now what I do is this negative sign, I shall take it in. So when I open the bracket, this negative sign would change the scenario here. It is variable square minus constant square. That will become constant square minus variable square and dx. Now here I notice it is 1 upon square root of constant square minus variable square. Okay, if you remember, this is 1 upon square root of a square minus x square dx. A square minus x square dx. And what it was, we had written this as sine inverse of x upon a plus c. This is sine inverse of x upon a plus c. So here this will become I equals to sine inverse of x minus 1 upon 2. Okay, we don't have to write plus c here because this is not indefinite, it is definite integration. So it is sine inverse of x minus 1 upon 2 and 0 to 1. Now what? Upper limit minus lower limit. Wherever x you have, you write upper limit. Got it? So you get sine inverse of 1 minus 1 upon 2 minus, you now write lower limit. That is, x is replaced by 0. So sine inverse of, you have 0 minus 1 by 2. So what you now get is I equals to sine inverse of 0 minus sine inverse of minus half. Sine inverse of 0 minus sine inverse of minus half. You know sine inverse of 0 is 0, and sine inverse of negative x. Sine inverse of negative x, remember, sine inverse of negative x is same as negative of sine inverse x. So this will become, the sine inverse of negative half will become minus sine inverse half. So that minus which you will write out, it will make this sign positive. So it will be plus sine inverse half, plus sine inverse half. And you know sine inverse of half is pi by 6. So you have I equals to 0 plus, adding 0 makes no change. So you have answer as pi by 6. This is answer for your question. We are now taking a new question. integral 0 to pi by 2 x multiplied to sin x dx. Definitely it is a definite integration problem. We are evaluating integrals which are under interval. So the interval here is 0 to pi by 2. Now I want to attract you all to this particular, I want to bring your attention to this particular function, x into sin x, x into sin x. Now this function, you notice that you got product of two functions. One is algebraic function and the other is trigonometric function. Now whenever we are integrating product of two functions like this, we use integration by parts. We use integration by parts, or we also call it as UV rule. Okay, UV rule. And what is that UV rule? UV rule is U integral V dx minus big integral d by dx of U integral V dx and once again dx. This completes integral UV, right? But here we have got the interval a to b. So if you have interval a to b, so the question is, see, the question is, after I applied the integration by parts rule, what happened was on the right hand side, I got three integral signs. You check this, you got three integral signs. So where do I actually write? Now see, this a to b has to be written now. A to b, when you had the integral a to b uv dx, you applied integration by parts. So you have three integral signs here. One is here, the other is here, and the third one is here. Where do you actually write these integral signs? Okay. So for that, what we will do is, see, we know anyways that after we will have integrated this whole thing, the final step, the final stage where the integration is over, the final stage where we will have integrated everything, what we do, we put that integral in a box and then we write lower limit, upper limit. Okay, we write like this. After you will have integrated, you will write that expression in a box and you write lower limit, upper limit. That is what you do in order to evaluate. So what we will do is, whenever we are using integration by parts, since we are having three integral signs, we would not be actually writing a to b with the integrals. Rather, we will put this in a box immediately in the first step only and write a to b. Remember what I said. Okay, see, let me take you back. Here. When I was solving this problem, I understood what type it is. And then I started working on that type. Now, while working on that type, that 0 to 1, I was writing 0 to 1 as it is. As it was in the first step, it was in the second step, then the third step, fourth step, fifth step. I was continuing writing 0 to 1. And when I had finally integrated it, I put that integral, okay, in a bracket and then I wrote 0 to 1. This 0 to 1 I wrote here. Okay. What would have happened if I had put a bracket here itself? Try to understand what would have happened if I had put a bracket here itself, okay, and instead of writing 0 to 1 here, I had written 0 to 1 like this. What would have happened? Just check what would have happened. The answer to this is, it would not have given me anything other than what it is giving me. That is, it still remains the same. See, now integration of this is 0 to 1. Integration of this is sine inverse of x minus 1 upon 2, and this 0 to 1 is 0 to 1. See, anyways you are going to write 0 to 1 for a box, for a bracket. So if you write right from the beginning or you write it towards the end, it means one and the same thing. But we do not write this way right in the beginning if we are having anything like this. If we are having anything like this, okay, because we have just one integral sign. Whereas here what we notice is we have got three integral signs. And since I have three integral signs, what I will do is I will write this in a bracket here itself, and then write a to b, and then write a to b. Once this whole thing integration is over, then evaluate. Okay, so I go ahead. What is my next step? My next step is to check whether this given function is in proper order or not. So order means Lie. Whenever you are integrating by parts, you use the priority code Lie. Logarithmic, inverse trigonometric, algebraic, trigonometric, and exponential. So here, what type of function is x? X is an algebraic function and this is trigonometric function. So the given function I have here, it has the order AT. AT. What order does it have? It has AT, right? And it has order AT, and the priority code also gives me AT. Okay, here also I have A, then T, and here I am having AT. So this order is proper. So I can go ahead and start integrating. Okay, so I write here integrating by parts, I equals to, I write here integrating by parts, and so I equals to u integral v dx. So x integration of sine x dx minus big integral sign d by dx of x integral sine x dx. Okay, and then I put this in a bracket again dx, and then what? Then put a final bracket here and write 0 to pi by 2. You understand the difference? Since we have more than one integral sign, we are writing right in the beginning this whole thing in a box and then 0 to pi by 2. So I equals to, you have integration of x, integration of sine x is negative of cos x, integration of sine x is negative cos x, minus big derivative of x is 1, and then again minus cos x and dx. Then you have here 0 to pi by 2. So the next you have is I, this is minus x cos x. Okay, this minus also comes out plus, this minus comes out plus, and here you have integral cos x dx and 0 to pi by 2. You have therefore I equals to, you have here I equals to, the integration is not yet over, it is minus x cos x and plus sine x. Derivative integration of cos x dx is sine x and 0 to pi by 2. Now see, inside you have no integral sign. It means now it is time you evaluated upper limit and lower limit, right? So I have I equals to, wherever x, write pi by 2. So you have minus pi by 2 cos pi by 2 plus sine pi by 2 upper limit, minus wherever x you have write lower limit. So 0. Okay, so this is minus 0 into cos 0 plus sine 0. See, everything is 0 here. Cos 0 is 1, but then 0 into 1 is 0, sine 0 is 0. So you have I equals to minus pi by 2, cos pi by 2 is 0, cos pi by 2 is 0, plus sine pi by 2 is 1, minus 0. So the final answer you get is 1. What is the answer? 1. I hope you all followed this series once again. Practice well. Let's take one more problem in definite integration where the function is product of two different types of functions. As you notice here, we have x into tan inverse x. X is an algebraic function and this is inverse trigonometric function. So in order to integrate this, I'll have to apply integration by parts. And whenever we are applying integration by parts, we are using the priority code LIATE, which we also call it as LIAT. And whatever the order you have here, you need to have the same order for the function that you are having here. So here in the integrand, what do you notice? You notice A is coming before I. A is coming before I. Here you are having A before I. But if you notice here, it is I before A. So what you will have to do, you will have to change this. Okay. So next step, I write 0 to 1, and this x into tan inverse x, I shall be writing tan inverse x into x dx. Now this is proper order. Okay. And we will integrate by parts. So I write here integrating by parts. Integrating by parts. This gets me I equals to u integral v dx, that is tan inverse of x integration of x dx minus big integral d by dx of tan inverse x, d by dx of tan inverse x integral x dx. This whole thing is put in a bracket, again dx, and once the whole integration by parts formula is applied, you will complete this in a bigger bracket and write the interval 0 to 1 like this. Okay, this is what is the major change in definite integration problem we have when we are applying integration by parts. So I equals to, you now have tan inverse of x, integral x is, as you know, it is x square by 2 minus d by dx of tan inverse x is 1 upon 1 plus x square, and this is again x square by 2 dx 0 to 1. Next step, I write here, therefore I equals to, I get here, therefore I equals to tan inverse of x into x square divided by 2 minus 1 upon 2, this x square by 2, so 1 upon 2 is out, and here I have x square upon 1 plus x square, which I can write as x square plus 1 dx and 0 to 1. Okay, I need to integrate this first, and then only I'll be able to apply upper limit minus lower limit. So x square plus 1 is in denominator, the numerator is x square. Okay, what I do, such problem we have done quite a lot times. So tan inverse of x into x square by 2 minus 1 by 2, and I will add 1, subtract 1. So x square plus 1 minus 1 divide by x square plus 1 dx and 0 to 1. So I equals to tan inverse of x into x square by 2 minus 1 by 2, and then the denominator we will separately divide for x square plus 1 and 1. What does that mean? I will write x square plus 1 upon x square plus 1 and 1 upon x square plus 1. So you can say that we are splitting the denominator here. So we will get I 1 upon 2, and I get x square plus 1 divided by x square plus 1, x square plus 1 divided by x square plus 1 minus 1 upon x square plus 1 and dx 0 to 1. So I get here I equals to, I'm sorry, it's not integral sign, tan inverse of, I get here tan inverse of x into x square by 2 minus 1 by 2, and this is 1 minus 1 upon x square plus 1 dx. That's it. Now I know I can integrate both these functions. I can integrate. I know I can integrate both these functions. Integration of 1 is x, and integration of 1 upon x square plus 1 is tan inverse of x. because the d by dx of tan inverse x is 1 upon 1 plus x square. So the next step you write is I equals to tan inverse of x, x square by 2 minus 1 by 2, and here inside another bracket you have x minus tan inverse x minus tan inverse x, and then complete it and 0 to 1. Now it is time we applied upper limit minus lower limit. One more thing, what I can do, this term has half in the, this term has 2 in the denominator, that is it is multiplied by half, and this term also, it has 1 by 2. So I can write that 1 by 2 outside the bracket. Okay, it will relieve me a bit. So 1 by 2 I write outside, it gets me tan inverse of x into x square, and I can open that bracket, minus x plus tan inverse x, and 0 to 1. Now it is upper limit minus lower limit. So we get here I equals to 1 by 2. Wherever x you see here, wherever x you see in this bracket, you write upper limit. So what you have? You have tan inverse of 1 into 1 square minus 1 plus tan inverse 1. Okay, this is upper limit. Minus lower limit. Wherever x you see, write 0. So tan inverse of 0 into 0 square. Okay, minus 0 plus tan inverse 0. This is your lower limit, the bracket to complete. So you have I equals to 1 by 2. Tan inverse of 1 is pi by 4, and 1 square is 1. Pi by 4 into 1 is pi by 4. Minus 1. Tan inverse of 1 once again. So plus pi by 4. See this tan inverse 1, I wrote pi by 4 into 1. So it makes no changes. Pi by 4 into 1 is pi by 4. Then this minus 1, and this tan inverse 1 is plus tan inverse 1. So once again I wrote pi by 4. Okay, this is a non bracket, and minus this, everything here is 0. See, tan inverse 0 is 0, multiplied by 0 is 0, and this is 0, tan inverse 0 is 0. So all are 0. So the next bracket is 0 here. So you get I equals to 1 upon 2 pi by 2 minus 1. This is final answer. 1 upon 2 pi by 2 minus 1. Or if you multiply this 1 upon 2 inside, so you'll get pi by 4 minus half. You will get pi by 4 minus 1 by 2. Whichever way you want to write, you can write it. This is final answer.